The game Blackjack is a popular casino game between the player and the dealer. The object is to be the closest to 21 without going over. Each numerical card is worth its face value, and each face card is worth 10 points, Jack, Queen, and King. An ace is either worth 1 or 11. The dealer deals each player 2 cards. Each player can then decide either to hit or stand, and the dealer continues to give them cards until they either decide to stand or they bust. The dealer's strategy is to always stand at 17. The only thing that the player has to be concerned with is beating the dealer.
Several studies have already been conducted pertaining to the game of blackjack. In the articles The Optimum Strategy in Blackjack and in The Statistical Analysis of Casino Blackjack, the researchers were primarily concerned with the strategy of card counting, that is, where the player determines whether they hit or stand based on what cards have already been seen on the table. There's another article, The Counterfactual Thinking and Confidence of Casino Blackjack, in which the researchers were more concerned with the risks that a player would take based on how long they'd been playing. For our study, we decided to take a slightly different approach and see if there was a general strategy that players could always follow that would be valid regardless of which cards had been seen on the table.
There are many strategies that can be deployed in the game of blackjack. One particular strategy is standing when a particular score has been reached. In this report, we investigated different scores to see which one was the best one to stand on. We gathered our data and analyzed it to determine what was the best score to stand on, and we found that the best score to stand on is 17, which is the strategy that is deployed by dealers in the casinos. Imagine that. In this case, our null hypothesis is that 17 is the best score to stand on, and our alternative hypothesis is that another score is the best score to stand on. In other words, that there is a better strategy out there than the dealer strategy.
For our inquiry, we want to know if the player should replicate the dealer's strategy or if they should use another strategy. Would you like to stand or hit?
Stand.
Would you like to stand or hit?
Hit.
Would you like to stand or hit?
I'll stand.
Would you like to stand or hit?
Stand.
Okay.
Well, no, not for each one, just a separate one.
Stand or hit?
Hit.
Stand.
Stand or hit?
Hit. I'm good.
Stand or hit?
Stand. Okay, so obviously we don't have the time to play a million games of blackjack, and you don't want to watch us play that many games anyway. So instead we're going to use the computer to simulate this data for us. What I have here is a program called Real Studio that's allowed me to create just a little program that will simulate these games for us and save us a lot of time. So, I don't want to bore you with the details, but basically this is the code that will simulate the game for us X number of times, so we can do mini games very quickly. And the dealer will always stand on 17, just like in a real casino, and the player will always stand on whatever value we tell them to. So we can try several different strategies and see which one's most effective. So we'll pull up the simulator. And it asks us to input the number of games, so we'll go ahead and do 1 million, which is probably overkill, but since the computer's doing it for us anyway, why not? And just as an example, we'll start out with 17, which is the same strategy the dealer has. And now we'll see just how the player fares when they emulate the dealer's strategy. And there we have it, 1 million games later. We have the number of times that the dealer won, the number of times the player won, and also the number of times the player lost by going over 21. And we continue to do this strategy for 15, 16, 17, 18, 19, and 20. And compiled all of this data into this Excel spreadsheet. Now this blue table here tells us all of our raw data from our experiment. As you can see, we tested these values and we got all of this data from the simulator. And we notice a few trends as the player actually seems to win more as their strategy for standing on the whatever value goes up. And also they seem to bust quite a bit more. But at this point with these numbers we can't tell a whole lot about what our experiment is telling us. So after analyzing it a bit more, we got these confidence intervals for the proportions of wins and busts given each strategy. And now we will go into a bit more detail about where these numbers came from and exactly what they mean for our experiment.
In our experiment, we're going to use the Agresti-Cool confidence interval. This confidence interval is good for when the value of n is greater than 40. And in this case, n is obviously greater than 40 because we're looking at 1 million games. In this case, x will be denoted as the number of wins. Our level of confidence that we want to be at is 99%. The z-value in this case is 2.5758. And here's how you find n tilde, which in this case is 1,006.6349. And here is how you find p tilde. Now, as we go over here, we can see this is the formula for the confidence interval. P tilde plus or minus the z-value, square root of p tilde times 1 minus p tilde all over n tilde. And in this example, we're going to look at when standing on 17. In this case, the number of wins for the player is 205,144. P tilde, as I've calculated, is 0.2051. So, as I set up the confidence interval, we get that we are 99% confident that the true proportion of wins when using the strategy of standing on 17 is between 0.2041 and 0.2061.
In conclusion, after analyzing our data, we determined that the dealer's strategy of standing on 17 was the best strategy because it had the greatest ratio of number of wins to number of busts. Our limitations for our data, however, were that our simulator shuffled the deck after each game. Also, we only used 1 deck of cards, whereas a typical casino uses anywhere from 4 to 6 deck of cards. For the future, we would manipulate our simulator to mimic that of the casino.